Hi guys, my name is Steven, and on behalf of my two corporate parking lot striper guys, Maddie and Carl, I'd like to welcome you back to my calibration channel. Today I want to talk to calibrators about alternatives to reading the gum if you want to increase your knowledge of uncertainty. I've been in the pharma industry since 1988. In the last couple of months, I've added about 300 new calibrators and measurement science people to my LinkedIn connections. I've also started making a series of videos about stuff I want to talk about. Some of those videos are very critical of the pharma industry. I've said at times that its practices are both unethical, extremely wasteful, and basically they're unsustainable. I've said that Western pharmas need to change their business practices radically or they're going to get disrupted. Now, the first time I said that on a video, I got a kind of creepy feeling, but now I think it's perfectly obvious. And if it's true for the industry, it's also true for most of the people in that industry. Now, to take this forward, I want to talk to calibrators because, as I've said previously, I carried a bag for 10 years as a calibrator. This is the practice and the group within pharma that I know the best. My message to calibrators is, given any instability in your particular part of any industry, the best thing you can do for yourself is learn more about the way measurement uncertainty works. That's because it's fundamental. It attaches itself to every single piece of data you collect for whatever company you're working for. I also believe that when, and not if, whatever industry you happen to be in gets disrupted, that disruption is going to move towards measurement uncertainty, not away from measurement uncertainty. That's because, again, uncertainty attaches itself so fundamentally to what we do. In fact, it's going to be with us as long as we have to make measurements to produce a product or service. And that's going to be a long time. Now, given what I've said so far, it would be pretty stupid for me to say, hey, calibrators, you need to read the GUM because the GUM is the highest level document that exists that describes measurement uncertainty. Oh, by the way, the GUM is practically unusable and there's no alternative. So bear with me. The GUM is a really poor resource for calibrators because it wasn't written by calibrators and it wasn't written for calibrators. Bear with me while I read a list of the 7 original organizations that produced the GUM. The International Bureau of Weights and Measures. By the way, their real title is in French. The International Electrotechnical Commission. The International Federation of Clinical Chemistry. The International Organization of Standards. Another organization whose real title is in French, not English. The International Union of Pure and Applied Chemistry. The International Union of Pure and Applied Physics. The International Organization of Legal Metrology. Now, it's easy to infer from just hearing the titles of these groups that when they got together, there weren't very many calibrators in the room. There was even fewer metrologists in the room. And yet, it's a miracle that they got together and decided they wanted to work on uncertainty as a target that they all needed to reach together. You know, when I look at the GUM, you know what I see? I see 100 to 150 thousands of hours of work, probably spread over 5 to 10 years. The GUM was a lot of work to produce. In addition, the GUM, although its title claims that it's a guidance, the GUM is really a memorandum of understanding between the 7 organizations that produced it. It's meant to stabilize and fortify the international commercial platform and to make trade across borders more transparent. It's what allows Toyota to sell to Chile or China, or GE to sell to Finland or Sweden. Now there's two things that prove to me that the GUM, as much work as it was initially, is still around. One thing is it's been supplemented regularly. The second thing is when I read just one of those supplements, I find it just as unreadable as the GUM was, which means to me the GUM political structure is still intact and still viable. Now I implied earlier that I have alternatives that I can suggest to the GUM. The first one is right here. It's from the National Physics Laboratory. It's called Good Practice Guide number 11. It's a beginner's guide to uncertainty of measurement. It's written by Dr. Stephanie Bell. It's superb. Dr. Bell writes for beginners, but she doesn't ditch any of the fundamental problems that have to be confronted even if you're going to make an advanced estimate of measurement uncertainty. In addition, she's very clear about what she's going to talk about and what she's going to leave out. It's superb technical writing. I've continued to go back and read it again long after I understood every single one of the points she was trying to make. Now the second document that I have to recommend is also from England. You know, what is it about the English? When they really get down and try and write something clear and simply, they're very, very good at it. Maybe it's because they're writing in English. The second document is from an organization called UCAS. It's the United Kingdom Accreditation Service. The name of their document is also quite romantic. It's called M3003. Now, I've talked to people at UCAS about who produced this document. I'm told it's a he and that he retired many years ago. When I try and imagine what he was like, I imagine someone who is trying to write both for beginners and advanced practitioners because he says so explicitly. I also imagine that this person felt no need to try and imply any legal authority that he did not have in the first place. Also, this person felt no need to try and intimidate his readers by using technical jargon. In addition, he had one other advantage. He was a single person, writing with a single idea and a single vision. And it shows clearly in his document. He was not trying to report on the results of committee meetings about some aspect of measurement uncertainty. I'll close by issuing a challenge. Print the first 10 pages of the GUM. Print the first 10 pages of M3003. Stick them side by side. Read one stack and then read the other. I can practically guarantee you that when you finish, you're going to run back to the printer and get the rest of M3003. It's easy to read, it's enjoyable to read, it is superb technical writing. I'll leave you with that. I've promised that what I'm going to talk about next is at the heart of estimating measurement uncertainty, and that's something called orthogonality. Stick around while I explain it. In the meantime, thank you for your attention.